Hello, this is Dr. Amgapriya, Associate Professor Tripli, Rohini College of Engineering and Technology, Palkulam. We are discussing about the course Power System Operation and Control, and in this lecture we will discuss about Statcom. Statcom, they are nothing but the static synchronous compensator. It is a solid state switching converter which is capable of generating or absorbing independently controllable real and reactive power at its output terminals when it is being fed from an energy source. The Statcom is considered as voltage source converter that from a given input of DC voltage it produces a set of three-phase AC output voltages, each in phase with and then coupled to the corresponding AC system voltage through a relatively small reactance. This can improve the dynamic voltage control, the power oscillation damping, the transient stability, the voltage flicker control, and also the control of not only the reactive power but also the active power when it is being connected to the system. But it requires a DC energy source in such a condition. So while considering the Statcom structure, it occupies a small footprint. It is a factory built equipment, that way it reducing site work and commissioning time. It uses encapsulated electronic converters, thereby minimizing its environmental impact. A Statcom is similar to ideal synchronous machine, which generates a balanced set of three sinusoidal voltages at the fundamental frequency with controllable amplitude and phase angle. So this is how the design of Statcom power circuit is being made. Here we do have two different voltages, which is ES and ET, supply voltage and the terminal voltage. So if ES is greater than ET, it generates reactive power. If ES is less than ET, it absorbs the reactive power. This is what is being the circuit explanation. And next we will considering when supplying or absorbing the reactive power, if suppose the amplitude of the output voltage is increased above that of the utility bus voltage, then a current flows through the reactance from the converter to the AC system, and converter generates capacitive power for the AC system. Obviously, the output voltage amplitude is decreased below the utility bus voltage. Then the current flows from the AC system to the converter, and the converter absorbs the inductive reactive power from the AC system. If the output voltage equals the AC system voltage, the reactive power exchange becomes zero, in which case the Statcom is said to be in floating state. In reactive power generation, the real power provided by the DC source as an input to the converter should be equal to zero. The primary need for the capacitor is to provide the circulating current path also as a voltage source. So in practice, the semiconductor switches of the converter are not lossless. So the energy stored in the DC capacitor is eventually used to meet the internal losses of the converter, and the DC capacitor voltage also will diminish. Hence, by making the output voltages of the converter, which is in order to lag behind the AC system voltages by a small angle, the converter will absorb a small amount of real power from the AC system to meet its internal losses. So we can see that when phase ES leads ET, it generates real power, and if ES lags ET, the phase value, it absorbs the real power. This is how when the case when supplying or absorbing the real power. Adjusting the phase shift between the converter output voltage and the AC system voltage, it can similarly control the real power exchange between the converter and the AC system. If the converter output voltage is made to lead the AC system voltage, then the converter can supply the real power to the AC system from its DC energy storage. If its voltage lags behind the AC system voltage, then it absorbs the real power from the AC system to the DC system. So this is how the VI characteristics are being obtained. We draw the inductive current versus voltage and capacitive current versus voltage. We can see how the variations are being made. So here we can see at the capacitance side within the transient rating itself, it shoots. So the maximum turn off capability of the converter switches will occur in this And for example, at the inductor side, when it shoots up within the transient rating limit, the junction temperature of the converter switches are being able to switch over the voltage. It is able to shoot it. So the Statcom can supply both the capacitive and the inductive compensation. So while considering this VI characteristic, it is capable of yielding the full output of capacitive generation almost independently of the system voltage. Hence, it supports the system voltage during and after faults where voltage collapse would otherwise be a limiting factor. So the maximum attainable transient overcurrent in the capacitive region is determined by the maximum current turn-off capability of the converter switches. But in the inductive region, the converter switches are naturally commutated as the current goes, when it is discharges.